In this video, we're going to model a set of data with a linear function. And it says two cars, each with a different volume of gas in their tanks, start moving at the same time. However, the volume of gas in their tanks is used up at different rates. Assume the volumes are changing linearly. It says the volume in tank, and they have gallons here. So for car A, after the first hour, it had 17.25 gallons, and then after the fifth hour, it had 14.25. Car B went from 19 to 15 over that time frame. It says, what was the difference in gallons of their starting volumes? Well, what I'm really looking for is what happened at 0 hours, okay, for car A and car B. I want to know what these two gallon amounts were and the difference between them. Well, to figure that out, I need to find the slope between the slope for car A and the slope for car B. So let's do that. I'm going to say M for car A, and then I'm going to say M for car B. Let's go with M for car A first. So that'd be 17.25 minus 14.25 over 1 minus 5. And then I'm going to do 19 minus 15 over 1 minus 5. In this case, I get 4 over negative 4 for the bottom one, which is negative 1. And then for this one here, I end up with 3 over negative 4, which is negative 3 over 4. So negative 0.75. So this means that I dropped negative 0.75 here, but it actually goes up by 0.75 here, okay, because the drop has to be 0.75 as it goes. So if I add 0.75 to this value here would be 18 for car A. It started at 18. That's where I'm getting this negative 3 over 4 from. And then negative 1, I add to the 19, so I add a gallon to it, and we actually started at 20. So at time 0, this car B had 20 gallons, then it went to 19, then 18, 17, 16, 15 at hour 5, and the same thing with car A, except for it was dropping 0.75 gallons each time. So what's the difference between 18 and 20? We would say that there is a 2-gallon difference. Difference at time 0. Let's try a second problem. It says the enrollments at 4 different colleges over time are shown. Assume the enrollments increase linearly, and then they show you that your enrollment for each college. 2005 to 2015. At which college is the enrollment increasing at the lowest rate? Well, we know that the difference in time here is 10, right? 2005 to 2015. So let's find the slope for college A, the slope for college B, the slope for college C, and the slope for D. And they want to know the enrollment increasing at the lowest rate. So they want to know the lowest slope here. So we're going to go for A. We're going to start with 15,600, and we're going to divide it by 2015 minus 2005. That's just 10. So we're just dividing by 10 for that. 15,600 minus 9,600. Sorry. Doing it in my head, but not doing it on the paper. And then we're going to have 17,500 minus 12,500 all over the 10 years for B. And then we're going to have 39,900 minus 30,900 all over 10. And then we're going to have 30,800 minus 22,800 all over 10. So when I subtract here, I end up with 6,000 over 10, which gives you 600. So we're increasing enrollment by 600 there. 17,500 minus 12,500, that's 5,000 over 10, which is 500 for a slope. And then I end up with 9,000 over 10 here for 900, and 8,000 over 10 for 800. So which has the lowest rate? That would be College B. They're going up at 500 per year comparative to the other three colleges that are going up at a faster rate.